Okay, so these are Redox short answer review. Make sure you've got your reference table and potentially a calculator, and that's it. Okay, so it looks like there's a lot to read. I know you don't want to, but we're going to do it anyway. Base your answers to questions 1 through 3 on the information below and on your knowledge of chemistry. Fuel cells are voltaic cells. In one type of fuel cell, oxygen gas reacts with hydrogen gas to produce water vapor and electrical energy. The unbalanced equation for this redox reaction is as follows. So let's show that. A diagram of the fuel cell is shown below. During an operation of the fuel cell, hydrogen gas is pumped into one compartment and oxygen gas is pumped into the other. Each compartment has an inner wall that is a porous carbon electrode through which ions flow. Aqueous potassium hydroxide and the porous electrodes serve as the salt bridge. Here's the diagram. All right, so we've got, it's a voltaic cell, so it just looks different than how we're used to it, where you've got the 2 half cells, salt bridge, strips of metal, and the voltmeter. So it looks slightly different, but we got the same idea because we got the porousness, got the 2 components. All right, balance the equation below for the reaction in this fuel cell using the smallest whole number coefficients. All right, so, well, let's do scorecard. We've got 2 on that side, 2 on that side, 2 on that side, 1. So how about we put a 2 here, which will change the hydrogens to 4, and we'll change the oxygens to 2, because remember this is distributed to everything. And then oxygens are good, but hydrogens are not, so we'll have to put a 2 there, changes that. And so once our scorecard is good, we're good. Now, you don't need to write a 1. Don't do it. Determine the change in oxidation number for oxygen in this operating fuel cell. Well, here's our reaction. We went from O2 to 2O, because remember that's distributed. Oxygen is a free element on that side, and in this side, it's got a -2 charge, because of course, H2O plus 1 minus 2, so assign oxidation states. And so it did not ask us for a half reaction, but if you wanted to, you could say, well, 2 times 2 is minus, 2 times -2 is -4, so you would have that. But it didn't ask us for that. All it asked us to do was to say, what is the change in oxidation state? So you can say, you could write this, I suppose, but how about from 0 to -2? That's it. State the number of moles of electrons that are gained when 5 moles of electrons are lost. So remember, this is the law of conservation of charge. It says you cannot gain or lose anything different. So if 5 moles are lost, 5 moles are gained. And don't tell me why or because. Didn't ask for that. So just say what the answer is. Okay. Base your answers in 4 and 5 to this. A student constructs an electrochemical cell during a lab investigation. When the switch is closed, electrons flow through the external circuit. The diagram and ionic equation below represent the cell and the reaction that occurs. Okay, so this is a voltaic cell. I know that for many reasons. The voltmeter, the 2 half cells. Yeah. State, oh, and here we have down here the reaction. State what happens to the mass of the Cu electrode and the mass of the zinc electrode in the operating cell. So you have to talk about both. So I guess we need to figure out who is the anode and who is the cathode. So don't forget the fat, red cat, 8, and anorexic, ox. So don't forget that the cathode is where reduction occurs, and fat, and it gets larger, and oxidation occurs at the anode, and it gets smaller. So we need to go to table J, and we need to figure out who is higher. So we have copper and zinc, I think. Is that bad? I don't remember. Hold on. Copper and zinc. So copper is here and zinc is here. So zinc is higher, which means it's active and it's more easily oxidized, which means we're going to lose electrons from there. So back to this. Redox. Nope, not that one. So we said zinc was more easily oxidized. So this is going to lose electrons. I'll use a different color. Lose electrons, which means this is the anorexic ox. Electrons are going to go this way. E. And so then the Cu's in solution are going to jump on here, getting this as the fat red cat. This side's going to get larger, larger, larger. And since this is losing electrons, this is going to be dumping zinc ions into solution, getting smaller, smaller, smaller. So it says, what happens to the mass of the Cu electrode? The Cu electrode increases in mass. Zn electrode decreases in mass. Notice it doesn't ask you who's the anode, who's the cathode. It didn't tell you any of that. It just says what's happening. So I guess you could guess, but let's not do that. Then it says write a balanced equation for the half reaction that occurs at the copper half cell when the cell operates. So we already decided that it's going to be reduction. And reduction is a gain of electrons. So in solution, oh, and also you can just use this right here. Don't forget. So who gained electrons? Cu plus 2 or 2 plus. Cu 0. So we're good on mass, but we're not good on charge. And so we gain electrons. How many? 2. Because plus 2 minus 2 is 0. That side is already 0. Okay. All right. Number 6. The balanced equation below is a decomposition. Determine the oxidation number of chlorine in the reactant. So this is how they're going to get you. Because guess what? They're different. So if you do the oxidation state of this chlorine, it's going to be different. So you don't want that one. That's products. So we have KClO3. Now, the 2 that's here, just don't worry about it, okay? Because that's part of balancing the whole reaction. So we need to go to periodic table. And I think, whoa. Yeah, that's what I feared. It was to the side. So we need oxidation state for potassium. Oh my gosh. What is happening here? Sorry about that. We need potassium, we need chlorine, and we need oxygen. So potassium is a plus 1, and chlorine, well, we got a few choices, and oxygen's minus 2. So we've got -1, +1, +5, +7. So remember that. We said K was +1, which means overall +1. Skip Cl. Oxygen's -2, which means overall, this times this, we're going to give you -6. So what now? Now we have an overall -5. How do I get this to equal 0? Is if Cl is a +5. And let's just double check again. Cl does indeed have a +5. So that's what we want. And back to, no, this. So it's a +5. I really would put +5 and not just 5 because, be aware. Now, you technically didn't need to show any of this work, but it's going to guide you to the +5. Okay, read it. The catalytic converter in an automobile changes harmful gases produced during fuel combustion to less harmful gases. In the catalytic converter, nitrogen dioxide reacts with carbon monoxide to produce nitrogen and carbon dioxide. In addition, some carbon monoxide reacts with the oxygen, producing carbon dioxide in the converter. These reactions are represented below. Okay, so there they are. Determine the oxidation number of carbon in each carbon compound in reaction 2. So guess what? Reaction 2, I'm just going to cross it right off so we don't confuse ourselves. Each carbon compound. So we have CO and we have CO2. All right, so carbon has, I'm sorry, this is sideways, -4, +2, and +4. And oxygen is only a -2. So let's remember that. So oxygen's -2. In the first case, if oxygen's a -2, carbon has to be +2. So +2 in the first one. In the second one, we have an overall -4. So copper is going to become a +4. So let's not, confuse ourselves with that. So you have a +2, and then you have a +4. All right, last bit. The diagram below represents an operating electrolytic cell used to plate silver onto a nickel key. As the cell operates, the oxidation occurs at the silver electrode. The mass of the silver electrode decreases. Identify the cathode. So fat, red cat, 8, and anorexic ox. So it says the mass of the silver electrode decreases. So this is the anorexic ox, which means who's getting larger, larger, larger? That's going to be the key. So the key is the fat red cat. Identify the cathode, the key. You could call it the nickel solid, but, key is good. State the purpose of the power source in the cell. Well, this is electrolytic, which means it is a non-spontaneous reaction. So to force the non-spontaneous reaction to occur. To provide energy. You don't have to write all of this, just provide energy. Something. I'm going to read from the answer key. It says, the cell requires the electrical energy from the non-spontaneous reaction to occur. The power source causes silver atoms to oxidize. Okay. Well, okay. Oh, in terms of, let's change this up. In terms of silver atoms and silver ions, why the mass of the silver electrode decreases. Okay, so you have to talk about both. So, let's see. Well, how do we start? So we'll say silver atoms lose electrons and dump, silver ions into solution. Silver strip electrode will decrease in size. So you can also say that silver atoms become silver ions. You could say that, but you have to talk about why the mass decreases. It says silver atoms lose electrons and become silver ions. Some of the silver atoms become silver ions. Silver atoms are oxidized to silver ions. Okay. Well, that's pretty much it. Here's the answer key. Yeah, if you have any questions, reach out, please. Otherwise, thanks for watching.